My name is Aditya. I'm a senior data consultant at Mantle Group. I'll be a host for today. I'd also like to welcome my co-organizers for today's meetup, Jeffrey and Alim, who have also helped coordinate today's event. Before we begin, I'd like to acknowledge the traditional owners of the land on which we meet today. I would also like to pay my respects to the elders past and present. And a big thank you to DiUS for hosting us today and organizing the refreshments and the pizza as well. So I'd like to welcome Chris to say a few quick words.
Thank you. Welcome everyone. I'm Chris, I'm from DiUS. So if you don't know about us, we're a consultancy that specialises in emerging technology, but also digital product development, app modernisation, that kind of thing. So around since 2004, 150 people across Australia, New Zealand, Japan. We're delighted to welcome you all to our office and help yourself to food and drinks if there's anything you need. Don't be afraid to shout out to myself or Erin, who's also in the marketing team. So have a great night.
Thank you. Thanks, Chris. Some housekeeping points. Toilets are through the door on the right. We will have the doors open till around 7:10, 7:15 p.m. So feel free to network after the talks. Also grab some food and drinks if you haven't already. Before we get into the talks, how many of you have heard of DataEng Bytes conference or have attended last year? Can you get a quick show of hands? Okay, quite not too many hands. So to give you guys more insight into what it is, I'd like to call upon my colleagues, Jeffrey and Alim, to kind of walk us and give us some insights on what it is.
Good. Thanks everyone, and thanks for DiUS for hosting us tonight as well. So DataEng Bytes is a conference for data engineers. We've been hosting it for a few years, and this year we'll be back as well. So last year we were in Sydney and Melbourne. This year we're back in 4 different cities. So this is really the place to meet a lot of data engineers, learn about what's going on in the field. So we've already organized some locations within Melbourne where we will be hosting the conference. So this probably looks familiar. This is about 10 minutes away from here. We'll be hosting the conference this year at the Edge, which looks like a great location. We're trying to get more people than we had last year. So we want more speakers, more attendees, and we're trying to do multi-track as well. So if you're interested in data engineering, definitely try to come along to this conference. So I have a quick video, about 1 minute, about what the conference looked like last year. So it's a teaser from last year. So just like last year, we're trying to get like a mix of many local people. If you're a data engineer and you want to present at this conference, come along for that. So these are the key dates related to the conference. We recently opened both the CFP and the ticket sale. So if you want tickets pretty cheap, you can buy them now. They're still in the early bird sale. Get about half price what they would usually be, so definitely jump onto that. if you're thinking of presenting, you have some interesting story to tell, put in a submission for that as well. So show these QR codes at the end as well. You can scan them if you want to place a submission. But there's many good reasons to sign up as a speaker, so it's a great way to showcase what you're doing, what you're working on. You get to network with other like-minded people. You can really show off what you're doing as well. Now the most important part is tickets are on sale right now, and they're much cheaper than you would get them later in the year, so definitely try to jump onto this. They're about half price what they would usually be. And these will be up at the end as well. So you get a big discount, you can guarantee your spot at the conference. I think this year we can host over 300 people if I'm not mistaken, so we have a bigger session as well. And yeah, if you're interested, scan these things and sign up as soon as you can, I guess. And if you have any story to tell, you can already sign up for it. Once you put in your call for papers, you can still edit your abstract until the closing date. So. Thanks, guys.
Thanks, Jeff. So, a tech conference at Fed Square, The Edge, proper data engineering talks, doesn't get better than that, so get your tickets ASAP, that's what I'm going to say. Without further ado, let's get into the talks for today. First up, we have Gaurav Thadani from DiUS, who's going to talk to us about designing events with caution, the enterprise, the EDA journey. Fun fact about him, this is his first meetup talk, so let's give him a warm welcome.
Cool. Thank you, Aditya. Thank you, Jeff. Thank you, Aaron. Thank you, Chris. Thank you, Alan. Yeah, fun fact, this is my first meetup. Fun for everyone, not so fun for me. Yeah, so I'm going to be talking about designing events with caution, the EDA journey, and I don't know if anyone gets this, but when you do cloud or Linux based, like who am I? That's current session or session user. It's another meetup. So who's a login user? It's me. That's me. My name is Gaurav Thadani. I'm a lead software engineer. I'm a lead consultant, senior software engineer, and I like to work with data. And I work with DiUS Computing right here at the back. A little bit more about me. I'm a software journalist. I like practicing test-driven development. I hate mocks. Like to work with continuous deployment, continuous delivery, and a lot of data. Event streams, real-time event-driven systems, and some domains that I've worked with in the past, not big, but outside work, I don't like social media. So yeah, that's about me. But why am I presenting this? I always want to present at meetups, eventually present at conferences. Very ironically, my first submission was at Kafka Summit. This is not going to happen so easily. So I climbed the ladder. I've been with DiUS Computing for a while now, and you get to go to conferences every year. So I like going to conferences and meetups. It's a nice way to get away from work. You get to network with a lot of people, meet with folks you worked with in the past, and you have a few days of fun, food, beer, away from the project. And, but that's what I expect out of a conference. But what really happens is I get extremely inspired by people. I get motivated, like, oh, they look pretty good on stage. Their confidence on stage, their ability to make like a presentation so compelling, so impactful. So I come back and I'm like, I could do that. And then what happens is I get lazy. I let the time pass, I procrastinate, I add goals. And then, being a consultant, I've been a consultant for about 12 years now. I get the new projects. And then 2023 December, I'll be going for YAM again, and cycle starts. I'm trying to break the barrier today. I haven't. There's no contract, there's no agenda. Cool, so I'm just setting into the whole meetup with what I'm going to talk about. We all work at an organization or for organizations or clients, and they all in today's world are generating some form of data. Either it's very, very business relevant data. It could be, if you're an e-commerce website, your transaction, your shipping information, your payments, whatever, business relevant, functional data, which is very critical to your organization. Added to that, you are also generating your web and mobile data, your channels, usage, tracking, how long was my user on this page, what did they click, what is their journey through my user experience, customer experience. So that's the kind of data that we're all generating, right? Clicks, time spent reading, time spent viewing, what's the drop off. But that's the data that's generated. All of this analytics is done after the data has been generated. So that's called descriptive analytics. To define what it is the process of using current and historical data to identify trends, and then you are understanding relationships. For example, if I did a marketing event, I saw my usage of the app spike, but I'm looking at something historic. Apple released a new iPad, sales went through the roof. It is historic. It doesn't go deeper than that, right? The organizations in today's world want to use this information to another degree. It's called predictive analytics. You are now taking all of this information and you are running simulations and scenarios and what ifs. You may have heard these terms called Monte Carlo simulations, run what if scenarios. I'm building big data projects. If I do this, this happens. Predictive analytics, what might happen. Companies still want to push the boundary further. Prescriptive optimization. The definition of this is this involves making actionable insights based on forecasts from your predictive analytics. If this happened, recommend what I should do next. There are organizations in the USA, fast food organizations today like Chick-fil-A, say, I sold 100 burgers yesterday. Tell me how much should I procure today for me to make and sell. And it's giving you insights on dimensions that perhaps are harder for humans to perceive. So that's what it is, right? Now, as an emerging tech consulting organization, and like many of us when we work in another space, we all realize that we'd like to work more towards the right, because that's the fun, interesting, taking the organization to a whole new world. And we've done a lot of work. In fact, I think some of us here I'm aware they've gone to clients, they spent a couple of months, and then when they come back, I want to hear their cool stories. I'm like, tell me about it, and they're like, the data was crap, we can't do much. I got the files, they had no structure going forward. So I have been reading about this, and it's the data science chasm. Organizations are here, everyone generates this data, everyone generates analytics on what's happened in the past, but they're trying to cross this big pitfall and go into that space and use every buzzword in the world. It's not that straightforward. Now I'm going to talk a little bit more in depth about what's happening within the organization to give you context of where I'm getting to. Very classic, we all work for organizations again. They are divided into whatever you want to call them, platforms that don't have business relevance, but they are very crucial. squads that belong to departments or tribes, business units that get funding, do some work, have return of investment. All of them generate data in different forms and shapes and sizes. Now, these are just hypothetical shapes, but some of them are files, some of them are database dumps. I'm sure many of us have done batch jobs, like, hey, give me how much money have you spent last week? It's a batch job run of your bank account, as an example. But also what's happening is a lot of data that's being generated by some of these functional business units are real time, and they have a lot of relevance in the organization. They are catering to real-time use cases that directly connect to the customer. So business use cases are for the organization, real-time use cases are of the customer. So just the segregation. And I'm going to focus a little bit more only on the real-time data, because there's only one medium that we can ship real-time data, not by files, not by batches, not by CSV, but by events. So the point I'm trying to make is, if you assume all departments, all subdivisions of your organization are shipping us events, or are converted to events, you can actually fuel or empower the data layer, which is from the previous slide. You are empowering to cross the chasm. But the reality is the data quality is bad. Everyone says this. The data quality 3 years ago, the data was some shape 3 years ago, it is some shape today. But I'm trying to get historical data to predict the future. And you need to retrofit, correct in order to get there. I'm calling this, and this is my coin term, the data quality chasm. I don't know how will it ever fly, but anyway, so with this talk, what I'm trying to say is, when you belong or you work in any of these parts of the organization and you are involved in designing events, you're not just designing events, you're empowering a lot more of the business. You are fueling an organization to cross the data science chasm. And the Spotifys, the Apples, and every other large organization are big into it. And that's what you want to look at when you're doing your data strategy, and what sort of teams you're building. So yeah. Another thing is, when you're doing real-time data, the freshness is very important. What's happened right now is critical to a system. I could quote a few examples of Uber Eats. If there are spikes in your orders from a restaurant, you want to know now, so that you can brace for the next hour. If an hour is gone, the time is gone. So that's an example. Point being, it's not just an event. Let's give it its due treatment. When we are working in such games. So the main part of it, how do I design an event? I've heard the problem, I understand these issues, how do I design an event? Greg Young, who coined CQRS, keeping what CQRS is away, said this really nice statement. When you start modeling events, it forces you to think about the behavior of the system, as opposed to thinking about the structure of the system. Look at a system as a holistic black box. Don't look at what is inside it. So take your domains, take your product as a black box. What comes out of it is what you're designing. We might be embedded into a team. We might be looking, these are my data tables. No. Look at yourself as a consumer, not as a producer. When you're thinking about your domain, don't focus on table names, don't focus on class names, don't focus on nouns. Look at your system as a domain, a business unit, and focus on the verbs associated with the domain. Pat Helland used to work with Microsoft back in the day with SOAP, now he's with Salesforce. He always said there is a distinction, very clear distinction about the data on the inside versus the data on the outside. And again, that's something we need to start cultivating as we're designing events. To give you a little more, maybe a valid example, if you were designing a database, you probably will raise events, transaction log updated or inserted, or tail log updated, or commit happened. Nobody consuming the database cares. They care when the row was updated. So you've got to raise the right events for the right consumer. And keep your internal stuff inside. Think about your external box, your bounded box. Another example which may be more relevant is on an e-commerce website, you have a shopping cart where you add and remove stuff, and then you place your cart. When you place your cart, shipping, payment, or kicks in. Items removed from cart are irrelevant. They care about the data on the outside, whether the order was placed or cancelled, not whether the item was added or removed. So you have to think of it within your bounded box. How do you do this though? Like, try to understand who's communicating with whom. Think of your business unit, talk to your product owner. I'm not going to get into the details, but event storming is a very good way of doing this, where you bring people together, whiteboard, read about it. I don't want to spend time, it's a lot of information online. But event storming is a good technique to get started when you are modeling events. On the right side, there are four aspects or 4 dimensions you need to consider when you're thinking events. And like I said, it's not just an event. So discuss this with your team, your product owner, and understand what you're doing, why you're doing. So one thing to remember is events are not commands. If you are issuing, it's an example where you are issuing to print a piece of paper, you are informing a printer, print this. That is a command, it's not an event. Your intention is for the printer to print it. It's directed, it goes to a single destination, and it's modeled around broadcasting to a printer. It's a computer in itself, but you're telling it a command. An event that you are generating as a domain is not that. It just happens. An order was placed in my system. I don't want to know, or I'm not bothered about whether it was shipped. The organization is, but me as an order domain, perhaps is not. It's anonymous. It models personal commerce. It models what you are trying to convey, and that's it. Not telling someone what to do. And the focus is local. The focus is within your domain. Moving on. Also discuss or think about what my event means. Like if it's critical for people to know, it's critical for consumers to consume, it's all right. And there are semantics that are associated to it. And I'll give you examples. If I am ordering an Uber and I want to track the live location of the Uber, and let's assume the Uber is sending it to me every 1 second, I don't need to deterministically get the location every 1 second. If a couple of them have been missed, it's okay, as long as I get the latest. So delivered at best. There are definitely reasons for it to be delivered deterministically. If the shipping or the payment system are subscribing to the order system, they need to know deterministically that an order was placed, otherwise they can't proceed further. So that's the different semantics you're thinking about. Another one is replayable. Let's say you didn't have the data team or your analytics happening on all of these systems, and they start now, but your business is 5 years old. They want to replay from the beginning of time. So you should be able to replay all your events from the beginning of time. So persistence is a concern. So in some cases, you don't need to persist your events. It's just my live location, Uber as an example. It could be persisted till it's delivered. Once it's delivered, I don't care. Or you could be PayPal. It needs to be delivered, it needs to be persisted because I need to be compliant with government regulations. So I just stored it in a Kafka topic for 7 years. So yeah, some examples out there. I'll put these slides up on the meetup later. But yeah, what you need to think about is semantics of your event. Who's consuming, why they're consuming, what's the transactionality around it, and what's the duration of persistence around it. There's no clear way to find out what do you do with an intent. It's just a conversation that you have with your POs, with your team, aligned, perhaps something you do with event storming. And once you've understood a structure or category where they belong, lock it in. You live by that philosophy. Domain. So what is an event? We've used the word event so often, and it could be anything. It could be click, event, happen. But let's spend a minute and discuss what an event is. So an event is something that happens. This is by Google definition, right? It is something that happens or takes place, especially one of importance. We might have a morning tea for Easter. That is an event that's about to happen. But in our world, in the whole software, it's not something that will happen. It has happened. I can't publish information an order will be created. Nobody cares. So what? Tell me when an order is created. So we have to shift from something will happen to something has happened. In our world, it is definitely that. You never tell what's not happened. It represents facts of information. They are immutable. When an event has happened, you can never change it. You can technically delete it. You can remove it for compliance, GDPR, right to forget reasons. The reality is that still happened. You can disconnect it by techniques from the customer, that user, from the order, whatever, but you can't say it never happened. They accrue over time. It's just knowledge. So that's pretty much what you need to really know what an event means or stands for, right? That's your domain. In terms of, cool, now I know maybe some philosophy about this. How do I still model if I am Uber and I need to publish my live location? Cool, talk to your product owner. Again, align with your team, do the event summary. List down the events that you as a publisher need to convey, and that is what it is. It's not driven by the consumer. Invest in practicing domain-driven design. It is very crucial. Look at your system as a box. Discuss with your product owners on using these events as a service. Imagine if you had to empower a mobile app or a web app, but you're not building it. It's all driven by events. If you had Kafka streams or if you had topics, assume it's being built somewhere. So that's your first. Design your event strategy, keeping events first. It's the first-class citizen and not just an event and an afterthought. So think about the domain, have a philosophy, come up with an eventing strategy, and you will start seeing that it makes more sense. Metadata. Now, we've spoken about the domain, we've spoken about the intent behind it. You need to give out information that conveys, again, metadata around it. Always look for keys. You may have always seen, like, in principle, when we write a database row, we are like, oh, it has to have an updated time, it has to have a created time, it has to have a last updated time, perhaps even a soft delete key. We maintain that discipline with records in the table. I think we should start doing that with events. There are some metadata fields here which I'm going to quickly skim through, and you should try and ensure that they are there. Event time, it's the time when the event actually happened. The publish time is when it was published onto the queues, on the buses. They may not be the same, they may not be relevant for a consumer, but you just want to inform them. Idempotence key. It's a key that you are giving out as a producer for your consumers to not double play events. And order placed you don't want an order placed to be shipped twice. So when you raise that kind of an event when an order was placed, you're saying this was order number 1. The consumer is going to say order number 1 was shipped. If they replay events, they should be like, I already processed order number 1, I'm not doing it again. So you could use, in that case with an order ID, you could use that as an idempotence key, but try and have a more specific idempotence key. Ensure as a publisher, if you were to consume this event, you'd like to have that key. An ordering key, when you use systems which guarantee order like Pulsar or Kafka, you're going to get that out of the box with offset and partitions. But if you don't, if your system is async like a Google Pub Subs and Event Bridge, do publish an order key. It could be the timestamp now, or again something more deterministic. The source, who was the publisher of this information? Again, it might be of importance. I might want to subscribe only to information from a particular source. The detail and the detail type are quite interesting. Like, again, going back to as an e-commerce website, if I were working with orders, should my bounded context of the topic be orders, or should there be 3 topics, which is order placed, order cancelled, order created? Think about that. And in my opinion, they should just be orders, and within that, the detail type should tell them whatever was created, placed, cancelled, or deleted. Or should I have them 3 separate topics, but then you lose ordering. So that's very important. And then the consumers could deal with, filtering out of the detail type, just to know. And that's the same thing around the topic names and the number of topics. Please ensure that your topic names around these events are very closely bound to your domain. Don't create it because the consumer wants it. Do not have a V1 for consumer group A. Do not have a V2 for consumer group B. Then you are doing what we did with APIs or microservices. And then you're maintaining contracts. And then when you already invest so much, you're going to do double. Don't do that. Keep it very pure to the domain. So yeah, think about the metadata you want to publish. In general, try and have this. If it's not being consumed, that's all right. But it's a good investment to have. And very lastly, start contracting. What you're publishing. Aditya and I were just talking about our contracts, and you can do multiple things in this space. A couple of examples are, first you document your event catalogs. This is an image from serverless data, where they define what are the events that organizations or departments are generating, who subscribes to them. In this case, it's a data lake, but you are allowing for discoverability in an organization by using event catalog. We do, I'm sure everyone's seen this with organizations where you're like, give me a service catalog. Let's expand it, let's talk event catalog. I need to know who's generating what events. Validate your schemas on publishing. Again, it's a responsibility of the producer. As you publish, if your schema is valid, should it go out? If it's not, it should be rejected. This saves a lot of bad data from going out. Then perhaps you will go through evolution. You need to find ways to communicate it, evolve your schema in a non-breaking change. But use a schema registry. They are good tools to validate. If you don't have them for your particular technology, it is worthwhile to revisit that technology, see how you can do this. You can still do it if you, as a producer, write consumer tests. I produce this data, that's cool. I will write a consumer test to validate that this is how consumption should be. And you're publishing that as a contract. Tomorrow, if your schema changes, you will catch it in your CI/CD. There's a lot of stuff you still need to consider. It's not like, oh, I went from microservices and APIs to event-driven and the world is all rosy. No, you still, like we spoke about, evolvability, discoverability, are some ways you can address with the contracts, but governance, scalability, reliability are very important. Looking at governance, sometimes in your domain you have sensitive information that perhaps you don't want persisted everywhere, and it needs to be destroyed at some point in time or disconnected for the customer. You do have to put all of that in mind, whether you encrypt your events, whether you I don't know how you can expire events, but perhaps you have to bring techniques of this is a call back to the data, and you expire the call back to the data. I don't know, I'm just thinking a lot, but governance is another important aspect because your data might be valid on all these topics for 3 years, but a consumer might take it and process. So how do you validate? How do you enforce that governance? The list goes on. I think to summarize, what I'm trying to say today is data and the events we generate as teams or domains or subunits or business units, everyday work, will form the fundamental of your organization. It will help you cross the data science chasm. If your stakeholders don't want it, have the conversation with them and why we are investing this versus not, so the trade-off, use the levers. Treat the design of events very well. It will be very helpful in the future when people are called into work in the design, in the prescriptive optimization space. Thank you.
Do you have any questions for Gaurav?
Yeah.
Please.
Yeah, I have. So, when you're designing an event, what should be there? Like a good event have like a large payload or something could happen? Like what would be the optimal size of information inside everything?
So just to repeat the question, when designing events, should it have a large payload or should it have perhaps not a large payload? There are different reasons to have a large payload. I think like you could do broadly there are four ways in which you transmit events, like the thin notification events, and you give a callback to get data, the fact events which carry state, which are perhaps large. Then there are some events which carry the history or the audit of everything that's happened in the past. Or people are even doing just delta changes, like typically your bank accounts are done with CQRS, debit credits, and you aggregate to get the statement of your account. So I think it's very use case driven. I feel with one or the other type, the investment of everything is different. Like if you were to do CQRS, ordering, persistence, everything is a bigger investment. But if you were doing something like an email, I just need to notify that an email was opened, say a marketing team. I could perhaps have the email content or what they clicked on the event. So I think again it's use case driven. You may also need to consider your domain, like if your domain is a bank account, do you want it to have a large payload or do you want it to say the small payloads? A nice example that's coming to my mind, which I didn't have in the slide, is if everyone's familiar here with MyGov, and then from MyGov you subscribe or you link to different services like ATO, Medicare, and anyone can contact you for saying, hey, this is something you need to address. Now, if you remember and you go and see your inbox, all you will say is you have an email in your MyGov account. It doesn't tell you the what, but it just notifies you to go and check back that something bigger is there. So I would say it needs to consider sensitivity, the domain, and again, it's a conversation that you need to have around the payload.
Thank you.
That was a good question. In your last slide, there were some points that you mentioned regarding scalability, reliability, governance. There was one point, discoverability.
Yeah.
Can you give an example for that?
Yeah, so I think what comes to mind is you may now grow as an organization and everyone's publishing events. And how you discover it. We used to have service discovery back in the day where you would be like, oh, where's the endpoint for this service? Is it load balanced? What's its throughput? And you can just, instead of you going to the service directly, you went via the service discoverability to the service so that if they changed, you automatically reacted. I'm saying very similar for events, team publishing events should have discoverability information, the schema, the topic name, the brokers, how do you access, what's your ACLs, and what's your integration pattern to get. So discoverability meaning publish information that you can be discovered in a self-serve fashion.
More like a central location.
Perhaps, like your event catalog was an example of discoverability. Yeah.
Just following on from that, the event catalog, what sort of metadata would you envisage storing in your event catalog?
Definitely the Avro. Like if I was using Avro Kafka, I would say, what is my Avro schema? What is the description, definition of the fields? I would also add the precision of fields. Like if I was doing timestamp, what standard does it follow to? Another one that comes to my mind, and I have had a problem in the past, is when I was doing a pricing system, you had a price point of a particular product. Now you can't have a negative price, so you want to document what are your data ranges. 0 is my lowest, and there's no highest. Or if I am putting a coefficient, -10 to +10 is my range, and it's good because some people need to know, like if there is bad data that's published, that it might, a divider measure can just impact your prediction and, price everything wrong. I have seen that. I have actually seen Adidas slippers get priced for like $2 or something. It was incorrect, but we had a wrong divider measure. So I think data ranges is something I would definitely document in my event catalog.
Any other questions? This last one from me.
Yeah.
Sorry. About the boards for you, can you provide us some example about the
behavior of the system or the structure of the system.
Oh yeah,
Not
yeah.
exactly.
So I think let's assume I am Amazon and you're a consumer. You are going to be bothered about whether something was added to your cart, placed an order, and I shipped it to you, and when are you going to get it? So that's the behaviors the system exposes. But under the hood, Amazon might be using the AWS themselves and DynamoDB, and an event was or record was written in AWS in Dynamo, and that became a stream event. And I don't know, it went to SQS, SNS. That's the structure of the system. You as a consumer don't care about that much because you're a consumer. So when I'm saying when you're designing your event systems, you should look at it, you should design your events impersonating a consumer. So look at the behavior of the system that you are using, rather than as developers we know, oh, this is my database, this is my foreign keys. Yeah, so that structure, you have to forcefully remove that bias when you're designing events.
Thank you.
I have seen people, oh yeah, I can join a job, I can join and get data and publish that this is the foreign key. No consumer cares about the foreign key. Yeah.
Thank you.
So last one, do you have any thoughts or recommendations on, you're talking about retrofitting, right?
Yeah.
Like when event changes or evolves over time, but there are some old events and
Yeah.
new events. Any thoughts, good practices? Do you
Yeah, I think this is a very interesting one and can be a big discussion in itself. Like your domain can change over time. Like there are domains which will not. Like if I'm doing a payment today, a payment will be a payment in 10 years. But will it be? I might have made the payment today with cash. I might be doing it with Bitcoin. So your domain will evolve. And then how does that work out for downstream or upstream, right? And how do you deal with breaking changes? So if you, well, let's say 10 years down the line, trying to aggregate of payments right from the beginning, I want to see what's happened. It will break. It will definitely break a Data Lake or a Snowflake saying, I will get cash $10 every day till I got 1 Bitcoin, and now cash is 0 and I'm doomed. So yeah, I think as designing the system, you need to be able to evolve, brace for evolution, and if you need to start doing things so that you can allow for retrofitting, it's also very important. You don't want, I think it's the same, like think about the behavior of the system, and as a producer, you really, there's a lot of discipline that goes into it. It's not, the risk of sounding like a broken record, it's not just an event, it's a lot more, yeah.
Awesome. In the interest of time, I think
Yeah.
that's it. Okay. Next up, we have Gurpreet Singh Sethi, Partner Solutions Architect from Databricks, and he's going to talk to us about Delta Lake. He's got about 16 years of industry experience, and he's worked with a lot of databases. And fun fact about him, he likes photography, and he's got his own Instagram page. If someone's interested in that, hit him up later after the talk. Over to you, Gurpreet.
Cool, thank you. All right, so good evening everyone. My name is Gurpreet Sethi. Let me start by saying this: if you want to process 10 years worth of data, Snowflake will definitely be here. Cool. So thanks for introducing me. So I'm actually working as a partner solution architect based with Databricks, based out of Melbourne. My role is actually not working with the clients directly, but with the partners like DiUS, Mental Group, and so on and so forth. Try to work with them on any pre-sales sort of activities, plus increase the know-how for Databricks within the partner ecosystem, so that when they go to the client side, they can work better job. Cool. So I was actually thinking what to present, but then I need to bore you with a few of the slides because that's a must. So let's see what Delta Lake is. Okay, beforehand, how many of us are working with Databricks right now? Cool. Already. And how many of us understand what Delta is? Great. Okay. So anyone know what Delta is?
It's the changes compared to the baseline.
Sorry.
It's the changes that you have compared to the baseline.
Can you elaborate?
But you have something happened yesterday. So you compare the data to what happened the day before. So you have like a baseline version.
Okay.
What happened yesterday? What happened today is like the data of what happened yesterday.
Unfortunately, no. Anyone else?
So it's a file format that allows you to capture changes and maintain metadata about the definitions.
Spot on. Absolutely. Cool. So before Delta, we were actually like roughly around starting from before 2018 or something like that. Delta was not there. Before that, when we were working with Databricks, what we were doing was we were actually interacting directly with Parquet files. How many of us understand if you really want to perform an update on a Parquet file, how easy it is?
No.
Exactly. Because it's a dirty file, you need to read your data, you need to make the changes, put it into a new file, mark old file as deleted or do some magic with that so that it should not be read again. And while doing so, how many times your system might fail? That means you will be landing into a inconsistent data. Half of the data is written, half of the data is lost, and you are in a limbo, right? So that's where Delta shines. So Delta brings asset properties on top of your lake house. So traditional RDBMS that provide atomicity, consistency, isolation, default, perfect, durability. So that's what Delta brings onto the lake house, onto the data lake. Starting from obviously RDBMS and DiUS are there since 1990 or 1980s or something like that, to the best of my knowledge. And then 2010 or 11 onwards, all of a sudden the data lakes comes into the picture. Idea was that we're going to push all sort of data into it, we're going to bring value out of that. But quickly we introduced with a new term called as data swarms, because data was actually not what existed. We were not able to perform things which it originally said it will be able to do. How many of us agree on that? If we have came from that background. So that's where the Delta lake comes into the picture. Delta brings consistent view. Delta actually shrinks the difference of what exactly a data warehouse does and what a data lake does. That's what exactly Delta comes together. It bridges that gap and it provides you a Delta enabled lake, which we call these days as a lake house, which is a Databricks terminology. So what we're going to do is you might need to sit for extra 10 minutes because I have a few demos as well just to show you rather than slides. Just a few slides and after that we'll jump into the demo. So about us, of course, original creator of Delta Lake, Spark and MLflow and so on and so forth. Delta was till last year June, there were two versions of Delta. One which was available in the open source community and one which was Databricks proprietary. But in June, something happens to Ali Gorsi, our CEO. He said, open the floodgates, Delta will be available to anyone and everyone. Both what features we have available within Databricks and what's from the open source community, they both will be exactly the same. And from that point onward, kudos to him, whatever we release within Databricks is actually released into the open source community as well. Henceforth, you will see all the AWS world, Microsoft world, and GCP and all the stuff world. They are also coming into the rat race of Lakehouse, and so does Snowflake as well. Right? So Delta is a new standard for data lakes. It is an open format based upon Parquet. Your actual data is still being saved as a Parquet file, snappy Parquet file. If you go to the lake, you will see it's .snappy.parquet. What along with that we provide a transaction layer on top of it. Just like in any RDBMS, if I'm coming from the SQL world, you will be having a master file, secondary file, and then a transactional file. That's where all your transactions get logged, and then you perform your recovery and blah, blah, blah. The recovery part is still not there in Databricks, maybe in the subsequent years. But transaction layer is that magical layer which provides you capability where you can perform data warehousing workload as well on top of your lake, or you can actually perform traditional data engineering work or data science sort of workload as well, with any language being it's Python, R, Scala, or SQL. All four languages, you will be able to work upon the same data set. You need not to copy your data from a warehouse to a lake or vice versa just because you want to perform some sort of work onto it. Single copy of data, single source of truth can be utilized by any persona, data engineering, data science, or analytics for that matter. And plus now streaming as well. It uses Apache, it provides Apache Spark API to connect with, and now the SQL API as well. So, Delta Lake ensure data reliability. So as I said, we have a Parquet file. Once we create a Delta, I'll show it to you. once we create a delta table, you will see under the hood party files plus underscore delta underscore log folder. That's where all those transaction log files get saved. Any event, any changes that we perform onto the table, update, delete, or for that matter, insert, all of those things will be logged. A version will be generated for that. So based upon those versions, it keep track what changes I'm doing on top of my data set. And then delta engine, whatever the database delta engine is, once you run the query and you say select star from this table, give me ID is equal to so and so, it go ahead and read those transaction logs and try to give you data in an optimal way. There are, of course, there are multiple things while doing so, like Z ordering and so forth. Once you go into the deep, you will try to understand those kind of things like Z ordering, blue filtering for that matter. And recently we introduced something called as what we call point in time, pointy queries or something like that. I forget the exact name, that's a shame. So those kind of features it provides so that it can optimally provide you the data back. So henceforth, you need not to copy your data just because you want to do a warehousing load or a data lake kind of load. It provides ACID, it provides schema enforcement. I need, just like we were discussing, if your topic got changed and the structure of the data got changed, as a data engineer, it's a hassle for us just to again change my entire pipeline because the data source data has changed. So we have option where we can automatically evolve our schema. So if you design your pipeline, if you wrote down with the help of autoloader or delta live table for that matter, you can simply say, evolve schema is equal to true. And if your schema got changed, your source system previously was giving you ID, first name, last name, and now it gives you age as well. All it's going to do is it's going to automatically enhance your schema. Your pipeline will not actually break. From that day onward, obviously old value will be null, but from that point onward, to start populating your age column as well. I need not do anything. Unified batch and streaming. Autoloader delta live table, it uses structure streaming behind the scene. So that means I can run it into a continuous fashion or I can run into a batch mode as well. So now my streaming workload is running either in a continuous fashion or a batch manner. So it really, you really need not to have a two separate system because I have a batch data and the streaming data as well. You can run it in one single tool itself. Time travel and data share. So by default, Delta, because of these version information, it keeps 30-day worth of data history behind the scene automatically. That means if today I create a Delta table, for the next 30 days, if I keep on making any changes, I can always go back to a specific version of that specific table. How exactly I can use that? If let's say I'm going to deploy a change and that change goes here or there, I can easily roll back my data. I can simply say restore my table as a version this. So it's a quick way of me to go back to my old version of data as well. I can use that for the let's say if there is a data engineer who's working on a change, and then he on a big change or something like that, he needs a subset of data as of a specific version. He can just create a copy of that and then leverage that data into his own whatever branch or something he's working, and the rest of the folks can actually still work on that latest data set as well. So it can be anything. There is a common misconception that I can actually use time travel or those kind of things for SCD1 or SCD2, but that's not the case because it's only for 30 days. You can increase those numbers, but then your metadata will keep on increasing, your overall disk users will keep on increasing, your data engine has to work extra time in order to ramp up with all those things. So henceforth, it is by no means a replication or a replica of creating your SCD1 or SCD2. It is just for you to quickly look into how exactly your structure of table has changes over the period of time. If you are evolving schema, you can look into it, how exactly that schema has evolved as well. So those kind of use cases only. Any questions so far?
I'm interested in knowing what is the process of providing data reliability?
Data reliability?
Yeah.
So as I said, all your transactions are actually captured within the transaction log. So that's where all information gets saved. And the data and let's say there are two transactions who are trying to work on the same data. We work on a, what is that? What's that isolation level? Which one is, give me isolation level, sorry. What sort of isolation levels we have?
Read Amitas, read Amitas.
Yeah, another one, persistent something. Oh, what a shame. Sorry. So it keeps track, make sure two transactions are trying to write on the same thing, only one will actually succeed, the second one will not. So hence making sure that you are not losing anything which you are writing at the time of, because two conflicting transactions are trying to write into the same thing.
But when the data source is somewhere else, how it says that it makes data available, ensures data available?
So you are grabbing your data from the source system, you are landing into a landing zone as like you are working on Oracle or SQL or something. You have an extraction job which grab that data, put it into a landing zone, and then you write that data within data lake, right? So once you write your data into the lake, it is actually consistent over there. It is available over there. You will not be actually losing it. Of course, you need to do something on top of that. In the sense, by default, it gets replicated 3 times within Azure or AWS or something. But if you need to have a more robust thing, you might actually enable a geo replication or something like that for your storage, so that it gets replicated onto your DR site or somewhere else or something like that. So those kind of things can be done. When it comes to optimization, so that's where we provide indexing, we provide compaction, data skipping, and caching. So indexing in the form of Z ordering. So there is something called as, once you create your data table, you can Z order onto a specific column or a group of columns, ideally up to 3, not more than that, and that too if they are int, integer, and those kind of things, not on a string or something like that, because that will be, your speed will not be actually that great on a string or something like that. So that's what exactly Z order provides, or it provides compaction. Whenever because at the end it's just snappy party files which get written under the hood, right? So if I'm doing a small change, by default the size of the file will be 128 MB. The by default size within Databricks is. Once you write a one change, so that means 128 MB file will get written. So over the period of time, if I'm making these small changes, and every file just have a fraction of data into it, that's not optimal, because if I try to read it, it will be too many small or too many big file problem for me, right? So that's where it automatically performs compaction. Once you write your delta table, before giving you a commit or something like that, what exactly it does is, it compacts all those files. Existing files and the new files that you've written down, it tries to compact it into a 1 GB file. So it makes sure that we are not landing into a problem where I have too many small files kind of issue. At any given time, my engine knows that I just need to read these 4 GB files, and within that as well, my transaction log knows that if I Z order, that which file is what has the maximum number and the minimum number records into it, so that it can optimally perform data skipping for me as well. So that means it will not do a full seek, it will actually do a scan for me. Sorry, it will not do a scan, it will do a seek operation for me. That's what exactly data skipping is. Caching, of course, every worker node, because it's a distributed environment, every worker node has a cache onto it. So the recently used queries which are frequently accessed, obviously the data will be cached. So next time once you run the same sort of query, your control plane will not actually ask you to grab the data from the lake. It will just go and grab the data from cache and serve it back to you. Right, that's what exactly on these slides. And just a quick thing on what are the upcoming things as well. That is ingestion time clustering. Sorry. This is live, by the way. So ingestion time clustering, this is primarily for your fact tables, which are like when we are inserting data into a database, into a fact or something, it's ever increasing. Like let's say we have a date column, we keep on adding data for the new dates. Like if it is a sales system, you always keep on giving me data for the new sales, not for the old sales or something, right? So that's where this ingestion time clustering comes into the picture. Only for those kind of use cases where the date time field is actually being used. It will automatically flatten your tables. It will automatically index your tables based upon the date when the data has arrived, or the column which you specified as a date time in which you want to write that data. So that means I need not to create any Z ordering myself, I need not to run any optimize myself, which I was telling in the previous screen. So with those kind of fact tables which are ever increasing, and there is a date time column on which you access that data and process that data, and if you define that in that way, it will automatically track your data. It will automatically lay down the structure of your data based upon that date field, so that whenever you are performing a select or insert or an update, that's quick one. So it further reduces your time to perform any optimization or any sort of other things on top of the data. This is only for those kind of use cases. This is already GA. auto-tune for the Unity Catalog managed tables. How many of us are aware of Unity Catalog? Cool. So Unity Catalog is the governance on the lakehouse. Previously, everything was actually very much workspace focused. I'm not sure if you are aware about the workspace. That's what exactly the front end GUI is. I'll show you what exactly it looks like. That's your gateway to interact with Databricks. That's where normally your data science engineer or your machine learning or engineers and so on and so forth, they will interact with the system in that way. There is nothing like you download a SSM Studio or something, Management Studio, and start connecting to it. Nothing like that. It's an entirely GUI-based solution on the SaaS solution. So Unity Catalog is a governance platform on top of your lakehouse that manages all your user management, access management, and metastore management. So if within the Unity there are two types of table, one is managed and external, that's a different topic, maybe next month or something. So if you are creating a managed table and the size is lesser than 1 terabyte, your Unity Catalog will automatically perform optimization tasks and so on and so forth. All those extra goodies automatically onto it. I need not to do anything my side. So what we are trying to make sure is that we make a lakehouse which is self kind of healing. We need not to spend much time just on the traditional way of doing it. Okay, rebuild your non-cluster index or rebuild your cluster index and so on and so forth, those kind of things. So that's the next thing. Faster update plus photon deletion vector. So right now when we are performing a deletion on top of any data, like if I'm performing an insert, update or a deletion operations on top of my lakehouse, it's an instant operation. We instantly remove data or remove that Parquet file and rewrite data into a new file behind the scene. What we are trying to do is we are trying to shun away from that practice, trying to create another layer into it where all these records, all these deletes and all the stuff are managed as a separate transaction. And for you, for an end user, it will be instant commit. And then behind the scene, kind of treated as just like a garbage collector or something else which will be running, which will perform that heavy lifting of moving data and plugging data into one single file. So that I need not to instantly spend more compute time just because that delete is happening and the write is going on. So those kind of things are also, these are into the public preview right now. Yeah, lifecycle archival policy. So right now within Databricks, if I keep populating my lakehouse for 1 year, 2 year, 3 years, 7 years, and so on and so forth, the size will keep on increasing. So there is always the question that how can I actually archive my data? Right now, that option is you partition your table on a yearly basis or something, put those partitions into a separate storage account, and then move those into a cold storage or whatever it is, and so on and so forth. But then the archiving, while the time of retrieving that data, there will be a problem, right? Because it will take time to read data from those storage accounts. So what we are trying to build is we are trying to build a lifecycle archival support where you specify that data older than this will automatically try to archive into a separate storage bucket. That's the view. It's still onto the drawing board, but that's some sort of something is also working on so that we can provide you a feature where you can automatically archive. Sorry, can you please not take a picture? This is just under NDA. So yeah, so we are working on those kind of things as well. When you put that one and later on this says no, we are not providing it, I'll be in a suit. Cool. So yeah, those are the upcoming things which are coming up. Now we will be moving into the Delta, just to show what exactly and how exactly it looked like. So this is that workspace which I was talking about. So every workspace, every Databricks workspace, once you create, it has a unique URL. So Databricks is a SaaS solution. It's no on-premises, no hybrid or something. It's entirely into cloud, Azure, AWS, and GCP. There is no on-premises. That means you have to work into the cloud for that. Once you provision a workspace, a URL will be given to you. You will be accessing that. With that URL, you will be accessing to your Databricks workspace. Over here on the extreme left-hand side, this way, we have our personas. So if you see, we have data science and engineering, machine learning, and SQL. So these are the three personas which currently exist in the industry. I don't think so there is any fourth one right now. So that means all three will be accessing data from the same URL. All they need to do is change your persona accordingly, and based upon the persona selection, for example, if it is data science and engineering, all you can see is workspace, repos, data, compute, and blah, blah, blah. And if you change that to to a machine learning, you will actually see something else like experiments, features, models, and so on and so forth. And if you change that to SQL, then you will be getting a more of a like a SQL Server management kind of thing, where you can open up a SQL editor, you can look into your queries, your dashboards, and so on and so forth. That's how exactly your persona will actually change. Now, sorry?
Yeah.
Oh yeah, sure. Can we come at the front? Yeah, there are sofas. I'm trying to expand it. Is it better?
Yeah, much better.
Cool,
Thank
sounds
you.
good. Alrighty, so. Alright, so this is a new feature that we added, which is table of content, because what happens is within Databricks Notebook, it is just the evolution of Jupyter Notebooks, if anyone knows that. So Jupyter Notebooks, we just expanded that, created our own version of it, so that we can write cells and so on and so forth, and within that you can actually create a markup query text as well, just to give more insights at what exactly we are trying to do in this notebook, so that people should understand if someone open up a notebook, and I should not be simply writing queries into it, and the person will be understanding what the hell he's doing. So you can open up a markup text and you can write commentary that, okay, this cell is doing this cell is doing that, and so on and so forth, those kind of things. And with the table of content, you can easily switch between your notebook, because it might be like this notebook has roughly around 40 or 50 odd commands, and if I keep on scrolling down, it doesn't make any sense. If I give them a right naming convention, like in this way, I can simply go, okay, show me where exactly the merge data table is. I can directly jump onto that markup text. So it is easy to traverse through the notebook and so on and so forth. But that's not the intent. So normally what happens is, whenever you try to run a notebook, you actually try to connect it with a cluster. This cluster is a compute. So you need a compute system behind the scene with which you will be running. If it's a data science or data engineering, you will be spinning up a cluster, which will be a machine learning cluster if it is DSML, or if it's a data engineering, then a normal cluster. If it is a SQL, then it's called a SQL warehouse. It's nothing but a set of compute that you will be running. Like on this one, I'm actually running something on a Spark 3.3 version. It has a i3x large compute with 30.5 GB memory and 4 cores and so on and so forth. That's where exactly my command is actually running, and this is also behind the scene working into cloud. The compute and the storage resides within client's ecosystem. That's the biggest difference between Snowflake and us. Here, client is actually the custodian of their own data. There is no vendor lock-in. Delta is the open format. Almost everything like Power BI, Click, Tableau, or whatever it is, everyone can actually speak Delta language these days. So it's an open source. Today, if you are in Azure, tomorrow you want to move into AWS, you need not to do. You just need to, front-end changes need to be done, but your Delta lake, you can simply put that into a S3 bucket from ADLS Gen 2, and you're back into the business. You need not to make any changes into your data, because it's Delta, which is totally being, you can see that you can read the same Delta within AWS or Google or within Azure. You need not to make any change. Henceforth, it's an open source Delta format. And correct me if I'm wrong, within Snowflake, I don't think so that's possible. It's a proprietary. If you want to extract data out of that, you need to extract as a CSV or something like that, and then again put it into a different format or something like that. So, and over here, as I said, this is client's own ecosystem. You are the custodian of your own data. You can see what data resides within your ADLS Gen 2 or S3 bucket or Google bucket for that matter, how much size it's consuming, and blah, blah, blah. And the computes are also within client's own ecosystem. Computes until unless you're using a serverless. If you're using a serverless feature, then computes are into cloud within Databricks premises, but otherwise, those computes are within client's ecosystem, so you will understand how much your computer resources are you're consuming and so on and so forth, via your Azure cost management and so on and so forth. You can always do that stuff. So what we have over here is kind of a cell, like this is one of the cell. So with %MD, percentage called as a magic command. So I can write percentage and I can write markup text. I can write %sh and I can run my shell commands into it. I can type %SQL and I can run SQL commands, %R for R, Python for Python, and so on and so forth. So I can run any sort of those 4 or 5 commands, whatever we have over here. So for this lab, what I have actually done is, I have some data which is residing over here. So I have some data like these are the CSV and the JSON data types which I have. Like the first one is actually stores.csv. So this is the CSV data which I have over here. Simply I have ID, name, emails, and so on and so forth. We will try to read this data We'll try to read this data via Python, via SQL. We'll create a table. We'll try to execute queries against table. We'll try to insert on that table. We'll try to update the table, merge the table. Idea is that it's all still native RK, and I can run all those operations on top of it. I need not to find anything different, technology or something like that. Everything is pre-built in. You can blindly go ahead and start writing your queries in SQL and start accessing the system. It's no more a blocker that you have to have a Python or those kind of skills. With SQL, now you can actually natively write entire pipelines within SQL as well if it is a SQL native organization. Or you can actually use what we call it as a DBT. You can use DBT as well to create your pipelines as well, and then you can run complete ETL using DBT as well. All we are interested in, you should be running compute, that's it. Whether you're doing it via DLT or autoloader or DBT, it doesn't matter to us. Cool. So Delta table. What we have over here is, I will be reading that specific table. So this one says that my data is residing into this specific location, the one which I just now showed you over here, the store.csv. So this is a Python implementation. So what I'm saying is my data path is this, read a stores.csv file from there. So this is my variable, get data set location. The value of this one is this. So I'm reading that one and I'm saying spark.read. And then I'm saying option, header is equal to true. This file is a header. So file has a header into it. Infer schema true. Read the file and take your best guess whether it's an integer or it's a varchar or it's a float or something else. And automatically infer schema for me, I need not to provide any schema information at all. It will automatically infer schema. By default, it will, this is one file, but in the actual one, it can actually read first 50 gig data or first 1000 files to infer a schema information. If let's say at any given time for an entity you drop 1000 files, like what happens is if you try to migrate your data, for example, you will be dropping a lot of files. So to read those 1000 files, and based on that, take a wide guess whether it's an int or a varchar or something else, and infer your schema in that fashion. And then you say, this is the CSV path, and then what we are doing is we are just displaying that value over here. So this is, we are not saving this data as of today. We are just reading it and presenting it live upfront in the memory that this is what exactly this data look like. Now ID is being a character value, BNE02, of course it's a varchar or a string. You can actually expand the data frame and you can see whether it's a string or what columns and so on and so forth. You can look into that as well. And what I can actually do is I can use it, so that data frame is only if it is a Python implementation. But if I want to access this data via SQL, then what? I can quickly create a temporary view, df.create or replace view. It get created, and I'm changing my context from Python. So this notebook is actually Python notebook. I'm changing the context to a SQL by simply writing magic command %SQL and say select star from that specific view. Previous information which I read in the form of a data frame, now I'm actually reading in the form of a SQL view. It's the same thing, everything is in memory. I haven't persisted it anywhere yet, and I can access with any language, as I said, Python, R, SQL, Scala. R and Scala, sorry. Now, if I want to persist, all I need to say is create table stores using Delta. Starting from version 8.4 onward, you need not to specify even using Delta because Delta is the de facto standard. I think 7.3, sorry. Starting from 7.3, 7.3 onward, Delta is the de facto standard. You need not even write using Delta. By default, it will create a Delta only for us. All I'm saying is that create this table from this one and then create a table called as stores. And I'm doing the select star. Again, using SQL. Now if I go back to my data explorer and just try to see, okay, what exactly I have done. So this is kind of a data explorer for me. I have created a database called as behind the scene name as my name underscore bootcamp, and within that a table got created called data stores. This is that structure of that table. This is the sample data of that table. And the size of this one is 2.19 kilobytes and so on and so forth. So I can easily see this got written over there. Right. Now, what I can actually do is, just like I read that file using, just like I read the CSV file, I can actually read a JSON file as well. So this is a JSON example. Just to show you, there is a JSON called as product.json. This is that JSON file, which has an ID, which has a name, which has ingredients, which is again nested and so on and so forth. and I can simply read that file as well. All I need to do is change my my type of file and say it's not a CSV, it's a JSON. .json, it will automatically read the JSON and display that value to you over here. It's as simple as that. So all the CSV, JSON, tab delimited, Parquet, ORC, those kind of formats are already available. You just say .this, and start reading the file as is. And then you can persist that table. One implementation which I showed previously was create a view and then do a select star as part of create table as select star from that view. And that was a SQL implementation. Python implementation will be data frame dot write. The write is operation and saying write this data, persist this data, and then save it as a table called as product. That's the Python implementation of it. And of course, behind the scene, if I go back, I should be able to see my table over here. That's the product table which gets saved. And of course, a string, array, and so on and so forth. And if I click on the sample data, the same data, I will be able to see it in this side of the fence as well. Then, if I want to see what all tables available in my database, simple command is show table. And that's it. Now, you can see there are two tables, product and stores. And then there is a view called as store underscore CSV underscore file. Any reason why there is no database in front of it?
It's in memory.
Absolutely. Because this is in memory, this is not persisted. Now, I understand these are the tables, but I want to understand more about this table, where exactly this table is being saved. What are the data types? Whether it's a managed table, what format this table is actually being saved. That's where your describe extended command comes into the picture. You say describe extended in the table name, and it's going to print all that value for you. All the columns that I have, whether there is a comment given to that or not, in which catalog, that's where the Unity catalog things comes into the picture. I will try to take another session on that. So by default, single workspace has a height meta store. That's what exactly called as Spark catalog. If it is a Unity catalog enabled workspace, then whatever the meta store name you will be giving, that name will come over here. Which database it is, what is the table name, what is the type of table, is the managed table. Quick one, managed table is, like I created a table, I said create table this or df.write, I didn't specify the location for that. So that means my database is actually managing that location for me. That stands for, that's a managed table. If you specify location clause and say location, put it into abfss / this folder and blah blah blah, container and so on and so forth, that's external location, that means I provide that location, so that's what exactly will be here. So then it will be showing as external and that location will come into the picture, into this value, into the location clause. Provider is delta, as I said, you need not to specify from 7.3 that it's a delta, it's by default, but if you want to give, that's absolutely fine. So provider is delta, who is the owner, and so on and so forth. All those properties will come in, will be displayed over here. Now, remember we talked about that it keep tracks of all the transactions, history, and so on and so forth, all the versions. If you want to see what exactly that one is, command is describe history and the table name. That will actually give you the version information. So by default, once you create your first table, that version is 0. That is your first table, first time when you create that table. That's what exactly it is showing over here. That this is the version 0. This is the user ID, my user ID behind the scene. This is the username. He ran a create table as select operation. And then what exactly that operation does, that value comes into a format and so on and so forth. It also provides you information that via which, if I ran this notebook as a job, that job related information will come here. Otherwise, if it is coming via notebook or something, notebook, which notebook I ran this job from, which cluster, what was the isolation level, and so on and so forth, all that information will actually be available in this history, because all these things is saved as a metadata operation behind the scene. And see, because it actually, at the end, it's a file. So it keeps track that I wrote down one number of file written 1, how many rows written? Number of rows 9. That's what exactly the metadata or the transaction log behind the scene keep track of. That okay, that each operation, how many number of new files are written or what files I have deleted, if it is a compaction operation and so on and so forth. So it keep track of all that information behind the scene. Now the question arises, okay, we are keeping all these things behind the scene and so on and so forth. Understood, but over the period of time, your metadata itself can be a problematic thing, right? So that's where what we do is after every 10 commits, we actually perform a checkpoint operation where we actually consolidate this metadata as well. So that next time if I'm reading, I will be only reading that specific latest metadata rather than anything previously as well. So henceforth we are controlling the metadata growth as well.
Yes.
Yeah.
So this was a question actually. So what is the table, what is the data being appended or inserted or updated very frequently to this table? So you said it stores only 10 last changes, right?
It saves versions. By default, it will show you the snapshot for last 30 only. That's what I said. Your actual data is still persistent. It's just that for how long old data you want to see from the scratch, that only that capability will actually go away. That's it. So you will not be able to see changes on that table after 30 days. After 30 days, it will roll back to 31st day and so on and so forth. Your actual data is still there. It's not changing. It's just in which way that data has changed, that capability will actually be restricted after 30 days, only to 30 days. We'll show you how exactly it looks like.
Sorry, just to follow up on that question. Will it make writes slower because there's so much metadata management that goes into it?
No, no. Haven't seen anything like that, that the write itself is actually slow, nothing like that.
So in an incremental load, every time you add rows to it, it will keep adding one record for this thing?
It will actually keep generating a new transaction log file for me. It will not write to the existing transaction log file. It will create a new transaction log file for me.
And the checkpointing process will consolidate those 10 files
Exactly.
together?
It will behind the scene consolidate those things, and then so that next time when you read, you just need not to read onto those 10, you will just look into the one single thing. Now, adding column. You can actually add new column to the table as well. So this is again a Python implementation. I'm using Spark SQL, Spark.SQL, and putting a command alter table, blah, 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 and add a store country column into it. So this will actually add a new column into my table. I can perform update as well onto the same database, onto the same table. It's again a snappy Parquet file. I'm just writing update. Imagine if you were actually writing to the snappy Parquet, can you perform this update? Answer is no. You need to put it into the data frame, make changes into your data frame, and then again write data frame into a new file and delete the old one, and so on and so forth. So here it performed that change. I can do a select on that, and I can perform a count sort of operations as well. I can perform a group by as well onto the data. So now it is giving me information, okay, store country this, there is only one file. For country like Australia, there are 5, for New Zealand, there are 3 records. Again, onto the same Parquet file. Again, I can perform another update, again via Spark. Previous was a SQL, this is again Spark SQL. Again, I will be able to do it. And if I do a select star from stores, I will be able to read all the data and so on and so forth. Now, let me show you another thing. So if I will show you now merge example, how exactly the merge will actually work onto the same. So this is another table. All I'm doing is I'm actually creating another table called as update_store. I'm adding 3 new values into it. And then all I'm going to do is I'm going to use a merge on my store and this table, and then take a call whether it's an insert or it's an update on the query. So we created a new table called as update_store. And now I can write a merge, traditional merge statement. Merge into store using update_store. On update where store ID is equal to store ID. When match, then update the record set. When not matched, then perform an insert. I need not to worry about how it is writing behind the scene, what is happening behind the scene. All I'm doing is just doing the work via SQL. I can alter the table as well. I can change the table properties. I can add a new column into it or a comment into it. So every table row, every table you can add a comment. Every column you can actually add a comment onto it. Alter table name, alter column ID. Everyone knows this if you're coming from the SQL world. So the same thing now is happening onto a big data on your modern data cloud platform on the Snappy Parquet files with SQL. And now if you do a describe table, see it added a new comment into it. That unique ID for the store and so on and so forth. That easy. You can add constraints as well. So now I'm adding a new constraint on the store ID column, making it as not null. Let's add that constraint. Constraint got added. Now if I try to insert a new value, so see I'm not putting any store ID over here. So that means I'm giving store ID as null. Will it succeed? Let's see. It's going to fail. Column store ID is not specified in the insert or something, so it will not allow me to do that. Moreover, if I do a describe history now, so we have performed so many inserts, updates, and blah, blah, blah. So far we made 8 changes into this table. Everything is actually logged. This is what exactly the progression or the versioning I was talking about. 0 was when I created this, then I added a new column, then I updated that, again perform an update via PySpark, via Spark SQL, then I perform a merge, then I change my table properties, then I change a column, then I rename a column, then I change a column. All that is actually being logged. You can easily go back to any previous version and try to see what exactly this guy was at that time. That's what exactly is called as time travel. So I can say select star from store, version as of 2, where ID is equal to so and so. So this is the version information I was talking about. So if you say describe history, this will give you the version and the timestamp. You can see based upon the timestamp value as well, or based upon the version value as well. So this one will show you the data when it was as of version ID 2. So in the version ID 2, I was having my city column, my store ID column, country column as null, which I later on updated via PySpark. I specifically said ML02, make it as Australia. So this is showing me that time travel functionality, that I can see what exactly this table was when it was in version 2. And this is what exactly get rolled over after 30 days, the one which I was talking about. Your actual data is still intact. It is just the capability of seeing those changes over the period of time. Only that thing you will actually use after 30 days. And behind the scene, what it actually does is all those relevant transaction logs or the version files, it just removes them. That's what it actually does. Your actual data is still there.
So if the version 2 is more than 30 days old, we won't be able to see it.
Exactly. Now, this was, sorry. Oh yeah, sure. So there is a command called as vacuum operation that we need to perform on this delta in a regular interval of time. Vacuum will actually remove all the unwanted Parquet files that are older than this 30 days, because your majority of the space is actually being occupied by your Snappy Parquet file, because that will consist of data. So you need to perform a regular vacuuming operation on your lakehouse so that you can free those unwanted Snappy Parquet files. Your metadata related thing, that is done by DataEng. You need not to perform any sort of operation just to remove those older transaction log files. That will be done automatically by DataEng. Only the relevant Parquet files, for that you need to perform vacuuming. Most of the time we have seen, when a new system gets placed, when a new deployment does, people forget to actually run the vacuuming, and after 2 months they will say, why the hell my storage is 2 terabytes? And then we realize, okay, we didn't perform the vacuuming because all those unwanted files, which are already not required from the time travel functionality, are still lying there. So vacuuming is an operation that we need to design as part of our solution to run on a weekly basis or something like that, so that all those files get removed. Right, so change data feed, just the last quick thing which I want to show you. So in RDBMS, if you enable change data capture, it keeps tracks whether it's insert, upload, or delete. You can now natively perform that onto the lakehouse as well. All you need to do is table level properties, say enable change data field is equal to true, and after that, let's say if I say describe history, and if I perform a change on my table like this update, and so update delete, I perform 2 operations. And now if I create, if I again run something like a select star and so forth, I can easily see this is the version and all the stuff, what changes has happened onto my table. It will actually keep track of, so it will keep track of, whether I perform change type as delete or something, it will natively track all those things. Now you can use these change underscore type columns to write your merge statements in a more efficient way, whereby you need not to actually create a hash on the non-primary key and compare it with the incoming row and outgoing row. All you need to check is look into your primary key if row matches, then see your change type. If it is a delete, then perform delete operation. If it is insert, then perform an insert operation, or whatever you want to do on top of that. By default, it will actually show you 4 options, which is, where is it? Yeah, so it will give, if it is insert, it will be right, change type will be written as insert. If it is a delete, as you saw it was a delete. If it is an update, it will give you pre-image and the post-image. Accordingly, you can efficiently write your statement moving forward from that table onwards. So these are a few of the options, and obviously there is a clone feature as well, deep clone, shallow clone. That is nothing but if you want to create a copy of your data, like you're in production environment, you want to copy your table. What you can actually do is you can create a clone of that data and then point that data with a location to an external storage, and then you can put that storage with your dev or test environment, and then move your data on that side for a latest data set from the production and so on and so forth. So these are a few of the features that we have within Delta. That's what exactly Delta Lake brings onto the table, or a Lakehouse brings onto the table. That is running a single environment, perform all sort of operations, all sort of use cases on a single persona, on a single copy of data, without actually copying just for the warehousing or data center or something like that use cases. That's the beauty of Delta. Any questions? Yep.
So, sorry, going back a little, you mentioned that vacuum operation needs to be run as a schema level operation. You don't need to do it table by table, right?
Vacuuming is, yes, it's a schema level operation. Huh? No, it's a table level operation, sorry. Vacuum is a table level operation.
So I just need to pick all the tables from my catalog
Yeah.
and then just run
Yeah,
vacuum
you need
ones
to run
on it.
vacuum on that, yes.
And that depends on how frequently I'm updating them as well. Because more updates means more versions of the old file.
But any given time it will be for last 30 days. So any file which is older than 30 days, only those will be removed.
Can you set like a number of version? So let's say if you set it to 5, then if there's a 6th version coming in, then the
Absolutely.
oldest version gets purged out automatically.
So it doesn't purge. It will still be remain there. It is just that once you do a time travel, it will not show you any data for that. Delta engine will mark those version files as obsolete in its logic.
Files still there.
Those will still be there, but they will automatically be removed by your Delta engine, because it will run a kind of a garbage collector behind the scenes, which will remove those transaction logs. Delta will, the snappy parking, you need to run a vacuuming for that. And this 30-day settings, you can actually change that as well.
Alright, in the interest of time, Blueprint will still be available after the session. So a big round of applause. Just to wrap things up, I'd like to thank both Gaurav and Blueprint today for presenting us with some great, awesome talks, and I'm hoping all of you got some new ideas to think about and also explore later. A special mention and a thank you to DiUS for hosting us today. Awesome. Lastly, thank you to all of you for making it here today and attending today's meetup. We're always on the lookout for more speakers, so if you have, and we always want to listen more data engineering problems and use cases. So if you're interested in giving a talk, contact anyone from the meetup team, or you can also ping us on LinkedIn, or Peter Hansons, if you know, you can also message him as well. Yeah, and thank you so much for coming. Thank you.
Thanks everyone.